Welcome back to Low Stress Math with Mrs. Bono. This is independent practice for Lesson 2, Unit 6, Graphing Systems. I know you've had a lot of independent practice for this, and I told you not to do the checks, but I'm going to do the checks now because I want you to see how to do them. Now, if you didn't do the independent practice, stop now and do the problems. It's 3 pages, it's 9 problems. It seems like a lot, but it's not that bad. And you don't have to do the checks because I'm going to do them with you. All right, so take a minute, well, about 20 minutes. Stop the video and do the problems. You stopped the video, right? Okay, so I'm gonna go over how to do these problems. Now, remember, you want the problems in y equals mx plus b form, and this first problem is in y equals mx plus b form. The b here is 2. So you're going to begin at 2, and I already made mine yellow, so here's the 2. And my slope, oh, there's no slope. Yes, there is. There's really a -1 there. So my m is -1, and I'm going to put it over 1, because I rise 1, and I'm going to go left 1. So rise 1, left 1, all the way across. Rising and running to the left. Now, I could put more points, but actually that's enough points to make a pretty darn good line. Now, I'm going to follow the pattern all the way across to the end of the grid. And here we go. Lots of points, an arrow on each side, and that's graphed. This one is a little harder. Why? Because I have to add this x to both sides. Don't line them up because you know you don't want to do that. Bring down, this is 0. Bring down the y equals 1x minus 2. You know why I put that 1 there. So my b is -2, and my m is 1 over 1. So I'm going to rise 1, and I'm going to run 1. This is not bad. Look, I start down here at -1. Sorry, -2. Wow, look at me lying to you. Down at -2, rise 1, run 1, rise 1, run 1. Found my solution. Woo, rising and running all the way across. Now that's plenty of points to make line. Now follow it nice and straight. That's not very straight. There, it's straight. Here we go. Look, already found my solution. So I know that that's the solution. So I'm going to highlight over here a little bit. I like to write my solution in highlight. Why? So that you can see it and I can see it. Right. Write the original equation on the line. The original equation is -x plus y equals -2. And the original equation on this side was already in y equals mx plus b form. Y equals -x plus 2. And they cross right there at +2, 0. So my solution is 2, 0. 2 to the right, and it doesn't go up and down. So there's my solution. And I'm just going to put a little x and a y under here, because now I'm going to check that solution. Sometimes you have to do this XY thing. So what am I checking? I'm checking my point, 2, 0. What am I checking? To make sure that this is really a solution to both of those equations. So I know that x is going to be 2 and y is going to be 0. So I rewrite both equations. The first equation was y equals -x plus 2. And the second one, I have to go back to the original equation, -x plus y equals -2. So I'm writing down both my equations. And now I'm going to use my ruler to separate this work from what's going to end up on the next problem, because I want to make sure it looks nice and neat. And so I'm just going to put a little double line through here to say that, hey, this is not part of that. And I'm going to put a single line through these two problems because I don't want to make a mess. This is the original two problems, and now I'm going to substitute. X is 2, y is 0. So y is 0 equals negative x is 2 plus 2. Now, I didn't have to put parentheses around there because I'm not multiplying. I'm just putting it there. So negative 2 plus 2 is 0. 0 equals 0. This point is a solution. This point is a solution to this problem, y equals negative x plus 2. But in order for it to really work, it has to be a solution to both equations. So I'm going to check the same point in the other equation. Negative 2 plus 0 equals negative 2. So 2 is here, but there was a negative in front of it, making it negative 2. Y is 0, so negative 2 plus 0 is negative 2. That equals negative 2, so that checks. So the point is also a solution to negative x plus y equals negative 2. So it's a solution to both of those problems. Okay, that's how you check. You take that same point and you check it in both equations to make sure it's a solution to both equations. That's it, not too bad. Let's go back and try the next problem. That's not so bad either. Let's do this. Negative 1/4 minus 1. Y equals mx plus b. B at the back is negative 1. And m is negative 1/4. So I'm going to rise 1, but I'm going to go left 4 because it's negative. So I start at negative 1 down, oh, you can't see that part. Start at negative 1 down here, and I'm going to rise 1 and go left 4. Rise 1 and go left 4. Now, if I want more points, I can do the opposite. I can drop 1 and go right 4. Drop 1 and go right 4. And you can see those made a straight line. If you're ever graphing and your points are not making a straight line, you're not graphing a linear equation. Be careful. Okay, go through all your points, make a nice straight line, put an arrow on it, yada, yada, yada. Now, this one, there's always a problem, right? The second one is not in y equals mx plus b form. So I have to add 2 to both sides. And I end up with y equals 1/2 x plus 2. Okay, so I begin at the back at the b with 2, and I have m equals 1/2. So I'm going to rise 1, run right 2. So from this point, positive 2, I'm going to rise 1, run 2. Rise 1, run 2. I can go all the way across. I can reverse it, or I could just look at it and say, wait a second. If I draw this line through here, look, I know it's going to come right through that point. So I don't have to graph any more points if I don't want to. I already know that this is going to be my answer. Oh dear, I've messed up another one of my markers. I have got to be more careful. So write your equation, original equations on the line. So this is y minus 2 equals 1/2 x. And this line, I'm going to write it down here, is y equals negative 1/4 x minus 1. And now here, where they cross, at negative 4, 0, 4 to the left, not up or down, negative 4, 0. And there's my point that I have to check. I'm going, this is my solution. I'm checking my solution. So here we go. The point that I have to check is -4, 0, which is x equals -4 and y equals 0. So let's check those two. In the original equations, remember you're always going back to the original equations. And I had here y equals -1/4 x minus 1 and y minus 2 equals 1/2 of x. I'm going to fill in the numbers for both of those. So y is 0, so I start with 0 equals -1/4 times -4 minus 1. Oh dear, I might want to grab a calculator for that, because I'm a little lazy when it comes to fractions. I think we all know that. So let me just slide this over so that you can see Ty. You come over here. Here's Ty. Hi, Ty. And I'm going to do fraction -1/4. And remember, use this arrow to get off of the fraction and put parentheses, -4, close the parentheses, minus 1. Be careful. This is the negative sign. This is the minus sign. If you screw up and if you mess up and you put them in the wrong order, you're not going to be able to solve your problem. And look, the minus sign is much bigger than the negative sign. When you press that, you get 0. Look at that. Yay us. So 0 equals 0. It checks. So that means that this is a point on this line. Let's do this one. So I have here y is 0 minus 2 equals 1/2, and in parentheses, I'm going to put that -4, and 0 minus 2 is -2, and 1/2 of 4 is 2, and it's negative, so it's -2. So that one checks also. So this is a point on both of the lines. Yay, my checks work. All right, next page. Dun, dun, dun. More graphing. Yeah, but I don't have to check these, so it's not so bad. The checks are what take forever. Ugh, oh my God, there we were at them. Don't talk, Bono. Here we go. Y equals 2x plus 6. Begin at the back at the 6, and m equals 2/1, rise over run. So I begin here at 6, and I'm going to rise 2, run 1. Ugh, oh, bother, look at that. There's only 2 points. So I'm going to do the opposite. Drop 2, left 1. Drop 2, left 1. Drop 2, left 1. All the way across. Yada, yada, yada. Here we go. And I am going, now I'm going to check it because I did a lot of points really fast. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. I did them good. All right, there we go. And connect the dots. Here we go. Arrows on each side. And now let's do this one. I have to add 2x to both sides. Don't line them up, so you know bad things happen then. 2x minus -2x and positive 2x is 0. Bring down the y. 2x should go first, plus 6. Hey, wait a second. That's the same line. Yay us. All this is the same. So remember, put your ruler just a little tiny bit above or below the line that's already there, because you want the red line to show, but you also want it to go through the same points. So all the way across, so you can see there's a red line and a black line, and you put the arrows on the end so you see both of them. And now original equations, -2x plus y equals 6. And that other original equation is y equals 2x plus 6. And this has infinitely many solutions. And I am going to put a big cloud of happiness around that because that's my favorite answer. infinitely many solutions. Yay. Let's take a look at this one. Ugh, they're both in the wrong order. All right, so I'll do this one up here. So y minus 4 equals 2x. I'm gonna add 4 to both sides, and I get y equals 2x plus 4. What does that mean? My b is 4, my m is 2 over 1. Rise 2, run 1. And I'm going to start at b equals 4. So here we go, 1, 2, 3, 4. Rise 2, run 1, rise 2, run 1. I hate when that happens. And then I have to do the opposite. Drop 2, left 1, drop 2, left 1, drop 2, left 1, drop 2, left 1, all the way across. And double check that it's a straight line, which it is. Connect the dots. La 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 la. Looks good, looks good. Arrows on both sides. Now, to fix this one. And I have to add 2x to both sides. Negative 2x and positive 2x is 0. Y comes down by itself. I want to put the 2x first. 2x plus 4. Hey, wait a second. That's 2 times in a row. This is the same as this. This is this. So therefore, this is that. So put the line right on top of it. So you want to make sure you're going through the same points, but that you're a little off so the people can, the person grading it, me, can see that their 2 lines are through. I'm going to actually color that in a little bit better so it looks like the lines are the same. Let's make a really thick red line. Sometimes that happens, and make a really thick red line. And there we go. Now I have to write the original equations. So y minus 2x equals 4, and y minus 4 equals 2x. And I get to write, again, infinitely many solutions. Can you see that? Yeah, infinite many solutions. Put a puffy cloud of happiness around it, because that looks good. And, woof. Now these two. Of course, neither of them are in the right order. Oh, Patu. I'll do this one first. 2 plus y equals 2x minus 2 minus 2. Y equals 2x minus 2. So I begin at the negative 2, and my m is 2 over 1. I'm going to rise 2 and run 1. So start at negative 2 and rise 2, run 1. Rise 2, run 1. Rise 2, run 1. All the way across. And I've got plenty of points there to make a line. Nice and straight. Make sure you're going through all the points. So you want it to look nice. You know, if the ruler moves a little and it gets, you can always erase it or, you know, try that. Now, the red one, which I'm going to write over here. Y minus 2x equals 5. Add 2x to both sides. Y equals, this is 0, 2x plus 5. Begin at the back at the b at 5. And my m is 2 over 1. So I rise 2. I run 1. So I start here at 5. And rise 2, run 1. Oh, and I can only do 1. Drop 2, left 1. Drop 2, left 1. Drop 2, left 1. Oh, what are you noticing about this? Ooh, look at that. Those are parallel lines. Those are never, ever going to intersect because they have the same slope but different y-intercepts. That's what parallel lines have. So now write the original equations on them. Y minus 2x equals 5, and 2 plus y equals 2x, and this has no solutions. Nice and big, no solutions. Big puffy cloud of happiness. There's no solutions for that. Now, you thought we were done? We're not done. There are a couple of problems here. Now, the real problem is I have to look at these lines and find out what the solutions are. Here's the solution. And this one here, oh, you know what? Put some highlight by the solutions. And you know, highlight those y's as well while you're here doing it. This one is at -1, -2, -3, -4, -5, -6, +5, -6, +5. Huh. And then it says to check. You know what? Just cross that off. Don't check these. Not in the mood. I can do that because I'm the teacher. And this one has, well, it's not going right or left, so it starts with a 0, -6. That's it. That's all I really wanted you to do there. And now we have to do this. We have to go back and do the spiral, solving the equations. There's a lot going on here, so I'm just going to come and I'm going to separate the two problems so my work doesn't end up all messy looking. And thinking back, all the way back, how do you do this? Well, you have to first distribute that 2. Can you see? Make it a little bigger so you can see better. Distribute that 2. So 7k didn't change, -8 didn't change, but now 2 times k is 2k. 2 times 12 is +24. And the equal sign didn't change. Now what I'm going to do is I'm going to use the commutative property to move things around so my variables are together and my numbers are together. So 7k plus 2k. And then I'm going to take this -8, -8, and put it after the 24. Plus 24 minus 8 equals 52. 7k plus 2k is 9k. 24 minus 8 is 16 equals 52. What is this? Did I write an equal sign when I meant to write a plus sign? Really, Bono? 24 minus 8 is +16. I was doing so well. Right now it's just a two-step equation. I'm going to minus 16 from both sides. And 16 minus 16 is 0. Bring down 9k equals 52 minus 16. Well, let's see. 50 minus 10 is 40, 12, 36. I could have used a calculator just then, but meh, what do I need that for? Here we go. Divide by 9, and I get k equals 4. Put a puffy cloud of happiness around that because that was a lot of work. But it was a throwback, and sometimes that happens. All right, now, last problem. Yay. Start with distributive property. 6 times f, 6f. 6 times 5 plus 30. The equal sign doesn't change. 2 times f, 2f, and 2 times -3 is -6 minus 6. All right, I want to get all the variables on one side, all the numbers on the other side. I like to move my smaller variable to the larger one. So I'm going to subtract 2f from both sides. Why? Because when you go over that equal sign, you have to do the opposite operation. So opposite sides, opposite operations. 2f minus 2f is 0. 6 minus 2 is 4, don't lose the F, plus 30 equals negative 6. I'm going to subtract 30 from both sides. And positive 30 minus 30 is 0. 4F equals negative 6 minus 30 is negative 36. Divide by 4, divide by 4. F equals negative 9. Puffy cloud of happiness because we are so done with this. All right, I'll talk to you soon. Take care.